I'm going to show you how to solve for the integral of square root of 2ax minus x squared dx. First thing we're going to do is to complete the square. That would be square root of 2ax minus x squared minus a squared plus a squared. So basically we're just adding 0 dx. So in here, we could factor this, so we would get x minus a squared. So we would have a squared minus x minus a squared dx. To make our lines easier, we're gonna substitute. We're gonna let u be x minus a. Then du, we would have dx. Derivative of u is just dx. So we would be having this, the integral of the square root of a squared minus u squared. So from here, we know that we can do trigonometric substitution. So we would substitute u is equal to a sine theta. And from this, we know we can get this. Theta is equal to arc sine u over a. Du is equal to a sine cosine theta d theta. We're gonna derive that. We're gonna get this. So sine theta is equal to u over a from here. So from here, we're gonna substitute those values. So our u is a sine theta. So we're gonna, and our du is a cosine theta d theta. Then we're going to perform the square. That's a squared minus a squared sine squared theta. Then we're going to factor out a squared here. We would get a squared times 1 minus sine squared. So this is an identity that is equal to cosine squared theta. So that would give us this. So performing the square root of a squared cosine squared theta, you would get a cosine theta times a cosine theta d theta. So combining a, we have a squared, and since we know that that is a constant, we're gonna bring that out. We have a squared. The integral of cos times cos is cosine squared theta d theta. So we have an identity here. The identity is 1 plus cos 2 theta over 2 d theta. So to perform linearity, we have a squared bracket integral of 1/2 d theta plus integral of cos 2 theta d theta all over 2. So to solve for this, we have this 1/2. We're gonna bring out the constant 1/2 d theta plus bring out the constant 1/2 cosine 2 theta d theta. So to solve this, we're gonna let z be 2 theta. So dz would be 2 d theta, giving us d theta is equal to dz over 2. So substituting that to the original one, we have 1/2 integral of cos z dz over 2. Bringing out the constant, we have 1/2 times 1/2, that's 1/4. So in here, we know that the integral of d theta is theta, so we're gonna leave that first. So we have 1/4 cos z dz. So we know from our cheat sheet that we have the integral of cos z dz is simply sine z. So we're going to undo the substitution since we know that z is equal to 2 theta. We would have 1/2 theta plus 1/4 sine 2 theta. So sine 2 theta also has an identity that is 2 sine theta cosine theta. So simplifying, we will now get 1/2 theta plus 1/2 sine theta cosine theta. So we're going to substitute this, plug it in here. We have a squared 1/2 theta plus 1/2 sine theta cosine theta plus c. Now we're going to undo the theta substitution. So we would get, since we know that theta is equal to sine -1 u over a, so we would get this 1/2 sine -1 u over a. That's from theta plus 1/2. Since sine theta is just equal to opposite over hypotenuse, that would be u over a. Then here, we're going to cosine theta, that's equal to adjacent over hypotenuse. Adjacent is a squared minus u squared. Hypotenuse is a. So distribute a squared. We have a squared over 2 sine negative 1. Since in here we're going to cancel out a squared, since we have two a's in the denominator and a squared on the numerator. So that would leave us to u over 2 square root of a squared minus u squared. So next thing is we're going to undo the u substitution. As we know that u is equal to x minus a, you would then get a squared over 2 sine negative 1, x minus a over a plus x minus a over 2 square root of a squared minus x minus a squared plus c. So in here, this is similar to this. So we know that this is just equal to that, so we're gonna simplify that by just rewriting. That would be equal to a squared over 2 sine negative 1 quantity x minus a over a plus x minus a over 2 square root of 2ax minus x squared plus c.